Tiltrotors, capable of flying both as helicopters and as airplanes, have become modern stars. Here they are, flying heroes from the future and the cutting edge of the latest aviation ideas. Latest. It's pretty funny to realize how old are the roots lying under these latest ideas. Hello aviators, Sky here, and today we will return to the times when tiltrotors were actually the latest idea, and the grandfather of the current flying stars will become our guide. Standing before us is the Bell XV-3. The 1950s were the dawn of helicopters. Just recently being exotic, now they have become widespread, and delighted aviators with their capabilities, which seemed limitless. Almost. Even then it was known that it would be extremely difficult to remove one barrier. Helicopters are slow. And it was not a matter of insufficiently powerful engines or underdeveloped technologies. The problem was conceptual. The main rotor, rotating at high speed, forms a kind of disc. Meanwhile, it turns out that in half of this disc, the blades move forward, and in the second half backward. When the helicopter is hovering in the air or flying at low speed, it doesn't matter. But if you accelerate enough, the oncoming airflow increases the load on one half of the disc and almost levels the efficiency of the second. The helicopter turns into a kind of airplane which has lost its wing, with all the consequences. Engineers have been looking for solutions to this problem since the dawn of the helicopter era in the 1920s, and many companies from different countries studied their own concepts. Naturally, among them was one of the world leaders in the industry, Bell Helicopter. Bell got a chance to present its concept in metal in 1951. The Air Force announced the Convertible Aircraft Program, which was supposed to produce a machine that incorporates the capabilities of both a helicopter and an airplane, being able to take off and land vertically and at the same time fly quite fast. Of course, Bell took part in it. Their concept was both simple and complex. Most of the ideas on acceleration at the time were about adding boosters of various kinds to provide speed, as well as modifying the rotors. Bell rejected these options. The installation of boosters meant that the machine would have to carry additional systems on itself, which would work only during the high-speed flight stage and the rest of the time would be dead weight. In addition, they were still talking about conventional helicopter configurations, which means that the fundamental problem was not solved, but only moved a little further. Bell's plan was different. If you want a craft that can be both a helicopter and an airplane, then let there be a helicopter that can turn into an airplane, or convert into an airplane. Tiltrotors are aircraft operating in two modes. In vertical mode, they fly like helicopters. Their rotors are directed upwards and act as carriers, lifting and holding the machine in the air. During the transition to level flight, the rotors turn forward, acting as aircraft propellers, and the wing creates lift. The simplicity of such an idea was more than offset with a huge number of nuances of such conversion. I will note that this concept was not exclusive at all. Others tried to implement it, but nothing useful came out of it. Before. The technological development of aviation in the 1950s, as well as the experience and resources, gave Bell confidence that they could create such an aircraft. In 1953, Bell Helicopter won the Air Force competition and received an order for a research program with the creation of two flight prototypes. Initially, the project received the XH-33 index, where H stood for helicopter. But later it was changed to XV-3, where V stood for VTOL, vertical takeoff and landing, and the future helicopter plane was officially called a convertiplane. The work was huge, and even before the creation of prototypes, Bell, along with several research centers, selected the optimal layout by running various models in wind tunnels. The results were encouraging, and it was time to move from scale models to full flight test prototypes. In accordance with the plan, the engineers began to assemble two machines, and the first of them, with the tail number 54-147, was released in 1955. Let's get to know it better. The fuselage of the XV-3 is more like that of an airplane, with a large tail and a high-mounted straight wing with ailerons and flaps, on the tips of which propellers are installed. Outwardly, it looks like a helicopter with transverse rotors, like some large machines, but with a different functionality. The two propellers offset each other's rotation, so the tail rotor was unnecessary. The aircraft is not very large. Length 9.25 meters, wingspan 9.55 meters, height 4.04 meters. Its maximum takeoff weight reaches a mark of just under 2.2 tons, about half the weight of the UH-1, and Huey is not really that huge a machine. This weight was supported by a skid landing gear. The prototype's cockpit looks a little awkward, but it did its job. The view was good and it was convenient to work, and more was not required of an experimental machine. It had two sections. The pilot was sitting in front, and in the back was universal space, where it was possible to place the co-pilot, passengers, or stretchers. The military contract assumed the functions of reconnaissance, cargo transportation, and medical evacuation. But of course in practice the XV-3 never carried anyone except for test pilots. Now the most important part, making the XV-3 a tiltrotor. At the wingtips are rotors, resting against mechanisms hidden by pylons. The rotors on the prototypes were different. On the board 54-147, the rotor was rigidly mounted with 3 blades, 7.63 meters in diameter. The pylons housed electric drives, capable of turning the rotors 90 degrees in about 15 seconds. Meanwhile, the pilot could stop the conversion process in any intermediate position. The rotation of the blades was transmitted through shafts stretched through the wing to the engine. This engine is the Pratt & Whitney R985 AN1 Wasp Jr. Radial 16-liter 9-cylinder 450 horsepower piston. At first glance too conservative, but gas turbine engines were still not reliable enough, and the Junior was a well-tested motor. Bell, making an already risky machine, decided not to add themselves adventures with it. The Wasp Jr., along with the transmission, was located in the center section. Meanwhile, the transmission was 2-speed, which made it possible to change the speed of rotation of the blades in different modes. The prototype 54-147 first flew in August 1955, and the flight was successful. Alas, the success turned out to be short, and the helicopter builders faced the big problem of tilt rotors. When switching from mode to mode, not only the configuration of the machine changes, but also the aerodynamics of the flight and the operation of the rotors, and all this created much more problems than it seemed initially. The XV-3 could fly quite well in helicopter mode, but attempts to switch to airplane mode caused destabilization in the rotation of the blades, an increase in the load on the airframe, and strong vibrations. The machine was grounded and modified, but the results were insufficient. In October 1956, another such wave of vibrations was so severe that the machine lost control and fell. The tester survived but was seriously injured, while the prototype was practically destroyed. It was disposed of. When creating the second prototype, the XV-3 54-148, Bell seriously redesigned it. The engine remained in place but received a large air intake. The structure was reinforced and the wing received additional struts. The beautiful 3-bladed rotors were one of the main causes of flight stability problems, and have been replaced by 2-bladed, semi-rigid rotors, with more advanced control mechanisms and a slightly smaller diameter of 7.3 meters. To further test the reliability and safety, the assembled apparatus was blown in the wind tunnel of the Ames laboratory with the support of NACA, NASA's predecessor, and Bell had hoped that everything would work out now. It took quite a long time, and the XV-3 made its first flight only in January 1958. And the revision paid off. The tiltrotor began to perform much better, flew steadily in helicopter mode, demonstrated decent auto-rotation capabilities in the event of an engine failure, and soon learned to fly with rotors rotated by 30 degrees, accelerating to 110 knots. This is the maximum speed of the Huey UH-1. Not bad. But further tests showed that the vibrations were not defeated completely. The machine was once more sent to the wind tunnels and modified again. And soon the goal was achieved. The tiltrotor managed to enter the cruising flight mode with a full turn of the rotors to a horizontal position. The helicopter learned to become an airplane. It was a huge victory for Bell engineers. The XV-3 was the first tiltrotor of its type in history, which was able to fully realize its function, confirming the viability of the concept. Flight speeds have already easily overcome the mark of 118 knots. They also practiced takeoff with a run. The skid landing gear had received wheels, the rotors turned slightly forward gave speed, and the wing gave additional lift. It was possible to take off with a considerably larger payload. Standard practice for many Stovall-class aircraft, including vertical fighter jets. The next step was to test flight in a low transmission gear, which made it possible to reduce the speed of rotation of the blades in level flight. Tests have shown that changing gears allows you to achieve the same flight performance at lower engine speeds, lower fuel consumption, and lower vibrations. A whole lot of bonuses. In April 1959, the prototype went to Edwards Air Force Base for joint tests with Bell, NASA, Air Force, and the Army. There, the XV-3 made about 38 flights. During the flights, the tiltrotor was kept at a speed of 145 knots, and in a dive it accelerated to 160 knots. Practical ceilings were around the mark of 12,000 feet. But the XV-3 still had enough unresolved issues. Flight tests smoothly flowed into another series of wind tunnel runs, and fortunately for the engineers, the vibrations in the structure were no longer so aggressive. The machine was tested at speeds up to the wild 197 knots, but it was the extreme. One such run wore out the structure so much that the pylon and the rotor simply fell apart. This accident was not critical, but it put an end to the XV-3 program. In 1966, the work on it was closed. There wasn't much drama in it. The XV-3 was an excellent flying lab, proved the viability of the concept, and brought a mountain of knowledge and experience, but had no prospects for being put into service. The aircraft was quite demanding in piloting, and it pathologically lacked its engine power. The engine in the fuselage, with shafts stretching through the wing, was not considered the best solution. The power plant had to be arranged differently. And of course, the problems of being prone to unstable operation of propellers and vibrations were solved by a rough change and reinforcement of the structure, and these solutions were not optimal or complete. At that time, the helicopter builders did not fully understand the nature of this phenomenon, and it took years of research and the use of the latest computers to clarify all the nuances. Then, in the 1960s, the technology was simply not developed enough. They grew to the required level already in the 1970s, when Bell took to the skies the XV-15, which became a much more advanced tiltrotor and in fact the direct ancestor of the well-known V-22 Osprey. Meanwhile, the grandpa XV-3 was going to retire. By the end of the program, it flew 250 times, spent about 125 hours in the air, and performed 110 transitions from helicopter to airplane mode and back. The prototype survived, was kept in storage at several military bases, and then was restored and sent to the museum. On this, our meeting with the grandpa can be completed. It has given way to even more advanced machines, some of which already stand in front of us or will soon appear. Like and subscribe to the channel. And if you want to watch the videos early, see some exclusive behind-the-scenes content, or just support the channel, consider joining our Patreon community. Fast flights and soft landings to you.